So welcome and thank you for joining this nTopology webinar, leveraging design freedom to disrupt power generation. My name is Roger Smith and I'm the CEO and founder at Sierra Turbines. Along with Will Hastings and Ryan O'Hara from nTopology, we'll be covering how additive manufacturing of our 20 kilowatt Aurelius Mark I engine was made possible with the Velo Sapphire system and the nTopology tools. So Sierra Turbines was founded in 2017 and is based in Silicon Valley, California, not far from Velo3D's headquarters. We're a small team of industry veterans with expertise in business development, mechanical, aerospace, and software engineering. Myself personally, I spent 19 years at Apple Computer. The mechanical and aerospace team have a combined 30 years of experience in the gas turbine industry, having come from Rolls-Royce. And so we are a small team that has come together to really drive the performance for these small micro gas turbines.
My name is Will Hastings from Velo3D. I'm the Director of Aviation Power Turbine Solutions. Velo3D was founded in 2014 with the mission of unlocking metal AM for serial production. And like Roger said, we're based in Silicon Valley. And then myself, I come from 12 years of jet engine design engineering at GE Aviation. And then off to you, Ryan.
I'm Ryan O'Hara. I work at nTopology. We're based in New York City. And at nTopology, I'm our technical director of aerospace and defense. And we're focused on next generation design tools for engineers to enable geometries that they couldn't do previously. That said, I'll turn it back over to Roger.
Sierra Turbines' mission is to work on the advanced small micro gas turbines for a range of both ground-based and aerial-based applications. What we're looking at here is is the overall topology of our micro gas turbine. We've been able to consolidate the parts into just a handful of parts that will lead to the increased performance that you see here on this slide. And so since we formed the company in 2017, we've been talking to a handful of customers who have given us these mandates, basically. So they've been looking for increased performance from time between overhaul, power density, compared to the battery systems that they're using. And especially for aerial applications where 60% of the overall platform weight comes just from the propulsion, they've been very focused on weight reduction. And so we believe that we will be the best power generation technology for a whole range of applications. And again, getting back to what you're seeing here, our advanced design using the Velo platform has basically allowed us to manufacture, which is key to driving the cost down, being able to manufacture our overall engine component in a cost-effective manner. And so this is what the number one task that our customers have asked us to do is reliability, lightweight, and improved performance. And we believe that the collaboration effort with Velo3D and nTopology is the ideal solution to be able to meet these metrics that were presented here. So why additive manufacturing? And so additive manufacturing allows us to do part consolidation. And so for a micro turbine, reducing 61 different sub-assemblies into one is enabled by additive. And by that, we're talking about the fuel injection, we're talking about bearing housing, we're talking about conformal cooling channels and conformal oil lubrication channels. And so it's a significant consolidation of different assemblies into one unibodied assembly that allows also for lightweighting. By reduction of the individual components, we can lightweight this part where, compared to existing competitive engines in this category, we've cut the weight by 50%. And so for aerospace applications, when you cut your weight by 50%, that's automatically part of the increased performance that, has never been accomplished for these small gas turbines. And so it's the design freedom of the Velo platform, it's the design freedom with the nTopology platform that together, is the why additive manufacturing for this level of a component. And so the unite in a common goal. I think sometimes it's difficult when you see metal parts, you don't have an appreciation for what post-processing may have been involved. And so what we're actually looking at in this photo is, right off the build plate, there has been zero post-processing because the Velo platform is a support-free, non-contact recorder blade system. And so this is testament to the work of Sierra Turbines, Velo3D, and nTopology as to how we were able to build and produce multiple parts, multiple engine cores using this, this advanced workflow. And as proof to what's absolutely possible, here is essentially, right out of the Velo3D Sapphire build system, we're able to print multiple of our engine cores at once. And so I want to talk a little bit about HASTEX because, we're pleased that this is the commercial launch of Velo's HASTEX platform. HASTEX is a very, this is the material used today in existing gas turbines that are operating for thousands of hours. It's an incredibly robust material in which it's the performance in the highly oxidative environment of a gas turbine. It truly excels. We're pleased to be working with Velo to be able to showcase what is entirely possible right off of the build platform. And so here's testament to the support-free, non-contact recorder blade system on the Velo3D. This represents zero post-processing. And what is particularly important to Sierra Turbines and also to the manufacturing of microgas turbines is what we call the gas path. And this is a very close-up and real possibility of what's possible. Here we see the turbine inlet vanes as printed. There's zero post-processing on this image. And we believe this is literally the first time in history that you've actually been able to get this level of surface finish on a small, compact gas turbine. And so challenges of metal AM. And so this is what we're seeing here in this photo is essentially the current state of the art as exists. And to be clear, this is not what we experienced at Sierra Turbines. Post-processing of additively manufactured parts requires massive amounts of support removal. And, fortunately, this is not our part, but this is representative of what you would see with other platforms today. If this material were HASTEX, the cost just to post-process and remove these supports would outweigh the benefits of using additive manufacturing, even with the consolidation of 61 parts into one. And so, this is a very real situation of some of the challenges that are unlocked with the Velo3D platform. So in addition to, geometric freedom, which then comes with support constraints, all of these additional, post-processing certification of additively manufactured parts, are completely removed with the Velo3D system. Over to you, Will.
Thank you, Roger. So now looking at how do we at Velo3D eliminate the challenges for our customers and for the world here, it's really the first aspect is design enablement. So you can see a nice comparison here on the screen of how our process compares to other metal AM systems out there. And what really holds back a lot of the designs for additive out there on the market is this, what is often called the 45-degree rule. So you can see how with the existing systems, it really starts to deteriorate as you go to lower and lower angles, print angles. And yet on the Sapphire system, this is just as it came off the build plate, you can see this gauge block here where we're printing down to 10 degrees here. And in certain cases, we can actually print at 0 degrees as well, and just very consistent and clean surface finish. And as Roger mentioned before, this is really key when you start dealing with flow path surfaces or surfaces where surface roughness is a key concern. So what does this mean for the Sierra turbines part? Well, really, this is a nice depiction of what the part would be with the supports and what the 45-degree rule would mean on another system. And you can really see that the entire core is really just a solid chunk of supports. And really, given that there's no access, given the kind of geometry we're printing here, there's no way to remove the supports. And so this would really be a non-starter from the get-go. So now looking on the right side of the screen here, you can see how the Velo 3D printed part had no supports on the interior. And I really like this part because when Roger and the Sierra Turbines team came to Velo over a year ago, we took this part as a challenge because while we could print most of these surfaces already with our existing processes, we really had a challenge with the airfoils here at the top of the combustor. And so we handed this over to our process engineering team, and they came out with new processes to be able to print these very low angle, thin airfoils beautifully straight out of the printer. So this is really a testament to how Velo 3D goes about the business of enabling engineers and supply chains across the world. It's not about changing the part to the manufacturing process. It's about where is the next challenge? Where is the next metal AM part that's being held back from serial production because of the limitations of the existing processes? Those are the parts that we live for, that we desire to work on every single day, is what's the next impossible part that we need to tackle. So looking a little bit more as to how do we actually come together and produce this part. So first off, on the left side of the screen here is really what I would call the CAD files, the input files. And then on the right side of the screen is, as we work through this flow, the part is finished. So first off, we received the CAD model from the Sierra Turbines team, and then additionally, the mesh that we'll be talking through next with Ryan was brought into the Flow software. From there, a Velo build file and print file was created, and then this file can be printed on any Sapphire system that has HESLOY X worldwide. And so this is really a great aspect of the Sapphire system, is it allows the Sierra Turbines team to have a more robust supply chain and not just be tied to one single printer in a certain location, but really worldwide, being able to scale the supply chain. And then finally, we'll be talking about this as well as the SURE, which is really the quality validation aspect. Once the part's done, how can you confirm that the build went according to plan without having to cut it open and destroy the part? So looking here as well, just a few points about the printer. So first off, we have a 315 millimeter diameter build plate, and it's 400 millimeters tall. So as the Sierra Turbines team thinks about larger and larger turbines, we can support them for quite a while to serve their needs. Additionally, we have dual 1 kilowatt lasers in our system. And then finally, the materials available are Inco 718, titanium 6.4, F357, and HESLOY X now, which we've been working with the Sierra Turbines team for the last several months. And then finally, we have the non-contact recoder, which really is a key aspect of enabling engineers to have that design freedom. And then looking at the quality aspects, this is from a NASA document, but really one of the key challenges that we're also working to address is the confidence in the 3D printed parts. And with this, it's really attributed to our both the process control within the Sapphire system, but then this is also logged on the Sure system. So right here, you can see this. These are 2 screenshots of the Sure build report of the specific Sierra turbines build. So you can see right here, we're able to calibrate before the build, or we calibrated before the build even started, the optical cleanliness, the thermal sensors, the laser alignment, and then also the powder bed stability. So this kind of technology to be able to calibrate a printer before the build even starts is really unparalleled and something that Velo3D is able to uniquely offer our customers at this point in time. And then additionally, you can see that we have multiple sensors. There's actually over 800 different sensors on the printer that are being logged during a build. And you can see right here, there's peak height, for instance. So this is a control chart that's analyzing real time the 3D map of the powder bed that's being taken layer by layer. And then also there's other control charts such as the recirculation filter, and there's many more that are not shown here. And now I'll hand it over to Ryan to talk through how nTopology was able to work through the intelligent mesh.
So in terms of annulus lattice generation, so nTopology platform enables our users to easily generate an annulus lattice, specifically in this case for use with combustors, right? And what's important to Sierra turbines is that they can explore how these lattices more efficiently atomize fuel in their combustor. A key takeaway from our software is the use of these repeated workflows so that they can not only be used in this design, but that knowledge can be gained and easily applied to downstream designs or processes with confidence that things are going to work like they expect. And with that said, I'd like to hand it back over to Roger.
So what's left for Sierra turbines, or what's next for Sierra turbines? We're going to be testing and validating this in a combustive environment where we'll really put the Hastex material through its paces. And the information that we learn from that will feed back into refining the design. We're really looking forward to printing the rotating components, because this is also another area where we believe the Velo platform will shine. And so additively manufactured turbines has still been seen as you know, frontier technology, because we're not sure of what the material properties are. And so everything we've seen so far, we're really looking forward to working with Velo3D on printed rotating parts. And as a startup, Sierra Turbines is actually raising Series A funding. So, you know, in between engineering and fundraising, we're going to be busy in the next couple of months. So thank you very much.
And lastly, from Velo3D, again, it's been an absolute pleasure to work with Sierra Turbines and nTopology on this project. And if you'd like to continue the conversation, you have impossible parts and applications that you want to print, please contact us at info@velo3d.com. Thank you.